second subtopic. Okay, 2.2, to find the derivative and integrals of inverse trigonometric function. First, we'll look at how to find the derivative and the derivative of inverse trigonometric function. Okay, this is the derivative formula for inverse trigonometric function. Okay, the formula involving with inverse trigonometric function are listed as this table. Okay, using the chain rule method. Okay, if u is any differentiable function of x, okay, then the differentiation of the sine inverse u equal to okay, 1 over square root 1 minus u square times du over dx. Okay, where u is the differentiable function. Any differentiable function. Now we must multiply with du over dx. Okay, the second one is the differentiation of the inverse cos. So equal to negative 1 over square root 1 minus u square times du over dx. Okay, number 3 is the differential of tangent inverse u. So equal to 1 over 1 plus u square times du over dx. Okay, kita tengok pattern yang sama lah. Okay, differential of tangent inverse lebih kurang hampir sama dengan ni, number 6 ni. Differential of cotangent inverse, negative. For cotangent negative lah, negative 1 over 1 plus u square times du over dx. And then number 4, the differential of inverse secant inverse. Okay, 1 over the absolute of u times with square root u square minus 1 times du over dx. And the last one ni sama, bukan sama untuk negatif ni. The differential of inverse cosecant u is equal to negative 1 over absolute u times square root u square minus 1 times du over dx. So ada 6 formula lah. Ini pun awak perlu list down kan. Final akan diberi lah dalam list of appendix awak. Okay, tips to solve the differentiation question of inverse trigonometric function. Okay, there are 3 steps. Okay, first, in order to solve the differentiation question involving the inverse of trigonometric function, okay, the first step, you have to identify the major operation of given question. Okay, for example, you have to apply the sum rule and difference rule. Okay, second one, you have to apply the product rules if it involves the multiplication of 2 functions. And the third one, you have to apply the quotient rule if there is a division of a function u over v. Also, kat sini you have to apply if the question is complicated function, involve complicated function, you have to apply the ln. Differential of logarithmic function. Kalau complex function, ada complex function. Applykan ln. Okay, step 2, know how to implement the rules and differentiate the given function. And number 3, solve the question by using the rule in step 1 And then if the answer can be simplified, then please simplify the answer. Okay, look at example. Okay, find dy over dx for y equal to sine inverse 5x. Okay, sine inverse 5x, we follow formula number 1 and number 1. Dy over dx equal to 1 over square root 1 minus u square kan. 1 minus formula dia ni. So d over du, ni kita follow sine inverse kan. Sine inverse u, so equal to 1 over 1 minus u square. Multiple with du over dx. So okay, this question, okay, we can also let u lah. Using substitution and let u equal to 5x. Let u equal to 5x. Then du over dx equal to 5. Boleh masukkan lah 1 over square root 1 minus u square. U square is 5x square times with, we differentiate du over dx is 5. Multiple with 5. So we get this answer. Okay. Okay, look at this example. Exercise. Ni exercise. Ni kita boleh cuba juga lah. Okay, look at exercise number 1. Okay, number 1 ni. Ni okay kan? Cubalah. Okay, number 1 tengok exercise. Y equal to 2 tangent inverse 3 over x. Okay, this is u, function u. Okay, to find dy over dx equal to 2. Okay, the differential of tangent inverse 1 over, we use formula number 3 kan. 1 over 1 plus u square kan. So 1 plus u square, u is this function, 3 over x, 1 plus u square, 3 over x square. And then we multiply with du over dx. We differentiate this function. Okay, this function u equal to 3x negative 1. So du over dx equal to negative 3x negative 2. So we get negative 3 over x square. Okay, then we expand and simplify this answer. So we get negative 6 kan. 6 over, okay, ni awak kena expand lah. 1 plus 9 over x square. Okay, multiple with x square. Okay, ni awak kena simplify yang ni. Negative 6 over x square plus 9 over x square multiple with x square. Okay, ni boleh cancel. So we get the final answer is negative 6 over x square plus 9. Okay, ni. Awak kena simplify lah sampai dapat answer ni. Simplify. Okay, tak boleh tinggalkan sampai macam ni je. Macam ni ada fraction mesti ada numerator and denominator je kan. Okay, ada soalan? Ada soalan tak? Boleh faham?
Ya, madam, boleh.
Faham, madam.
Boleh? Tak ada soalan ni?
Tak ada.
Tak ada. Okay, number 2. Tu ni pun direct lah. Y equal to cos inverse x cube. So dy over dx. We use formula cos, so negative 1 over 1 minus u square kan. Square root 1 minus u square ni u. Function u. So x cube square. Okay, multiple with du over dx. We differentiate this function. So we get 3x square. Negative 3x square over 1 minus x power of 6. Square root 1 minus x power of 6. Secant inverse. Number 3. Okay, ni kita cuba buat sampai ni lah. Number 4. Okay, number 5 ni cuba buat sendiri Number 5. Number 3. Secant. Y equal to secant inverse exponent to x. So dy over dx. Now we apply the formula for secant 1 over that's the root of u kan. Okay, ni u. That's the root of u. So e to x square root u square e to x square minus 1. And then we multiple with, we differentiate this function u. So we get 2 exponent 2x. Okay, ni awak boleh cancel. Cuba dapat ni. Exponent 4x. This one. And number 4, y equal to 1 over tangent inverse x kan. Okay, yang ni awak boleh tukarkan kepada ni 1 over tangent inverse x is equal to tangent inverse x to power of negative 1. Boleh tak? Ni tukarkan kepada ni lah kan. Ni soalan dia ni original ni, tukar bentuk ni. Y equal to tangent inverse x power of negative 1. Kita nak bawakan dia ke atas lah. Kita tak nak dia jadi fraction. So dy over dx equal to, kalau fraction ni awak kena guna quotient kan. Tapi nanti kita guna ni lah. Okay, dy over dx. So untuk ni kita differentiate dulu lah kan. Ni kat sini. Differentiate luar dia ni. So we get negative 1 tangent inverse x power negative 2 kan. Differentiate. And then baru differentiate dalam dia ni. Differentiate yang ni baru. Differentiate tangent inverse is equal to 1 over 1 plus u square kan. 1 plus u square is x square lah. X square. Multiple with du over dx. We differentiate x equal to 1. Multiple with 1. So we get negative 1 over tangent inverse x square times 1 plus x square. Okay. So yang ni awak kena tahu ada 6 lah formula of the differential of inverse trigonometric function. There are 6 formula. Awak kena apply je lah. And then applykan juga substitution, using substitution. Kalau involve complicated function kan. Okay, ada soalan? Ada soalan tak ni? Differential of inverse trigo.
Tak ada.
Ada? Okay, tak ada. Last one. We proceed to the integrals. Okay, the integrals involving the inverse trigonometric function. The integration formula for inverse trigonometric function. There are 2 main formula for the integrals of inverse trigonometric function. Okay, number 1, we differentiate if we want to integrate the x over a square minus x square. The square root of a square minus x square. Okay, so equal to the sine inverse x over a plus c. Kena refer pattern yang ni lah, pattern ni. Okay, the second one, we want to integrate the x over a square plus x square. Okay, this pattern. So equal to 1 over a tangent inverse x over a plus c. Okay, untuk integration ada plus c lah, c is a constant. Kalau dia tak ada boundary. Okay, in another formula involving the integrals of inverse trigonometric function. Okay, ni sama formula number 1 tadi. And then, okay, ni pun sama formula number 2 for tangent. The arctangent means the sine, the inverse lah. The sine. Sometimes we call the arctangent or a sine for the sine inverse. For the arctangent, the sine, the inverse tangent or etan. Okay, number 3, ni new formula lah. Okay, number 3. Number 3, the integral of du over u times the square root u square minus a square equal to 1 over a second inverse. Okay, untuk ni second inverse Second inverse the absolute u over a plus c. Number 3 ni. Biasanya 2 ni kan, tapi aku tambah 1 lagi lah ni. For the second inverse. Okay, the important tips in solving the problem related to the integration. Okay, firstly, the student have to analyze the question, whether the question is more likely to the formula or not. Macam tadi lah, ada 3 patterns kan. Okay, if it like the formula, the student can solve the question straight away. If it's not, okay, the students can use other techniques of integration. Okay, so in this chapter, we only focus on the substitution. Okay, another techniques of integration we will learn in chapter 3, techniques of integration. Untuk ni kita hanya fokus kepada substitution. Chapter 3 baru kita tengok lah apa ada implicit ke apa kan, by parts. Okay, look at example. Example 1. Solve the integrals dx over square root 4 minus x square. Okay, ni tadi pattern apa? The integral kita tengok pattern number 1 lah kan. Dx over a square minus x square kan. Number 1. Ni. Pattern ni. So we apply lah. The sine inverse x over, okay, a tadi a square equal to 4, so a equal to 2 lah, x over a kan, so x over 2 plus c. You kena write ni c, kena tulis plus c. So example 2, if we have boundary, let's say boundary from 1 to -1. Okay, so this pattern follow the integrals of tangent inverse, tangent inverse x. Yang kedua tadi kan, tangent. 1 over a, tadi a dia is 1, so samalah. A is 1 plus, tadi kan 1 plus x square. So we substitute the boundary from 1 until -1. 1 minus -1. So akan dapat yang ni lah. Pi over 2. Okay, lagi satu untuk yang ni mod dia awak kena tukar kepada mod radian. Yang ni untuk trigonometric function calculator. Tukar mod calculator mod radian. Untuk calculator. Kalau tak tukar, tak dapat jawapan. Okay, example 3. Okay, use the integration table to evaluate. Okay, number 1 A ni. Okay, biasanya untuk yang ni apa? Ni awak boleh tukar lah kan. 1 over 3 square kan. 3 square minus x square dx. Okay, yang ni apa? Sin kan? Ni. Follow table. So, table formula number 1 lah. The sin inverse x over a. A is 3 plus c. Okay, b. Okay, 4 ni boleh bawa ke depan. So 1 over. Okay, ni kita jadikan a square. So dia akan jadi square root 3 lah. Square root 3 square. Square root 3 square akan dapat 3 kan balik. Square root 3 square plus x square dx. Okay, yang ni kita follow number 2 kan, tangent. So akan dapat tangent is 1 over a tangent kan. 1 over a is square root 3 tangent inverse x over a square root 3 plus c. akan dapat ni lah, ni boleh darab lah. 4 over square root 3 tangent inverse x over square root 3 plus c. Okay, C. Okay, yang ni dia ada boundary atau dia ada upper boundary and lower boundary, so boleh masukkan lah nanti. Okay, 2 1 over 2 square minus x square. Okay, yang ni sin kan, 2 sin inverse x over 2 into 1. Masukkan lah. Sin inverse 1 minus sin inverse 1 over 2. Okay, jawapannya 2 pi over 3. Tekan kalkulator lah yang ni. Okay, D last one. Yang ni tersilap ni boundary dia patutnya yang besar atas ni lah. Terbalik ni. 3 times 3 pi, yang ni 3. Ni terbalik lah boundary dia. One, okay, tukarkan 1 over 3 square plus x square. So equal to tangent kan, 1 over 3, tangent formula 1 over 3 tangent inverse x over 3. So boundary from 3 square root 3, 3. So we get 1 over 3 tangent inverse square root 3 minus tangent inverse 3. Okay, 1. The answer is pi over 36. Okay, ada soalan tak untuk integrals ni? So dah habis lah untuk ni. Ada soalan?
No, madam. Ada, madam.
Okay.
Ada, madam.
Okay, tak ada. Ni boleh cuba lah buat sendiri. Exercise ni. Habis. Habis untuk yang ni. Okay, so tadi buat mana? Buat exercise, buat ni. Siapkan ni. 1 until 5 for integrals and differentiation tadi. Number 5. Exercise. Number 5 ni semua A, B, C, D. C, D ni. And then lagi satu tadi tutorial 1. Yes, saya tutorial 1. Tutorial 1 for triangle lah. Yang tadi yang subtopic 2.1 tadi. Okay, tak ada soalan Tak ada soalan, kita boleh stop sampai sini. Okay, attendance, you all klik dalam your future. Attendance. Okay, so jumpa next class hari Khamis. Khamis nanti kita akan masuk topik yang baru. Boleh tak? Tak ke laju? Laju tak?
Madam, next class rasanya Jumaat.
Jumaat Jumaat.
Jumaat.
Laju tak saya nak masuk topik baru ataupun nak buat tutorial dulu? Sebabnya ni cover 2 subtopik. Triangle and derivative and integrals. Ke Jumaat tu nak buat tutorial. Ataupun saya nak habis apa balik. Kalau Jumaat Jumaat tu saya buat ni lah. Google Meet lah. Kalau tak, kalau nak buat exercise tutorial lah.